Hello everyone, welcome to my channel. So today we are going to do Leetcode weekly challenge second question. So let us first read these questions and constraint, then about the implementation for the same. Now here, smallest value after replacing with sum of prime factors. So we are given a positive integer n, continuously replace n with the sum of its prime factors. Note that if a prime factor divides n multiple times, it should be included in the sum as many times as it divides it. The smallest value of n that will be till now. So that is the thing which we are required to do here. Basically, 15 which is given to us. So when we will be doing prime factorization for the 15, then it will be 3 into 15, right? So this prime factorization sum now we are required to do, that is 3 plus 5, which will be 8. So that's why now n becomes 8. So when we will be doing prime factorization for this 8, then it will be 2 into 2 into 2, right? So then we need to do sum of this 2 into 2 into 2. So that will be 6. So now n becomes 6. Then do prime factorization for 6, that will be 2 into 3. Now doing sum 2 plus 3, and now that will become 5. If we do prime factorization 5, that will be 5 only. So that's why this is the answer, and that is what they are returning. So this is the thing which we are required to do. Basically, it is about finding out the prime factorization of a particular number, then adding that up, and then replacing that sum with the n. So here, what edge cases and what all things we are required to keep in mind is, first thing would be doing prime factorization. So whatever optimized way we can use for doing prime factorization, that we can use. Then second thing would be doing sum of the same. And third thing would be keeping a check that it doesn't give us TLE, or if to, because we are doing it repetitive, right? So there are some edge cases as well in the same scenario. Means in this scenario only, there is an edge case of 4. See, if we do prime factorization of 4, then it would 2 into 2. Then we add up, then it again becomes 4, right? So for this thing only, we are required to keep a check that if our sum and n are equal, then we are required to eradicate that scenario and move ahead. So that's the edge case for this particular thing. And these are the steps, means prime factorization, then sum, and then finally uh, looping this particular prime factorization and sum in such a manner that it doesn't give us TL. So that's the thing which we are required to do with this particular question. Now let us go ahead with the coding part for the same. Before that, about we can clearly see the constraints for the same is 10 raised to power 5, right? So basically we can get as big number as this. So according to that, we are going good. So now here, first thing is about prime factorization. So this all is about the prime factorization only, whose time complexity is this much. And then here we are just calling that prime factorization. And then comes our main algorithmic part, that where at that point we are calling that C. Basically, C is the most optimized way to call out our prime factor, means do prime factorization. So that's why I just use that C algorithm and implemented the same. So here, first we are calling C so that we can easily do prime factorization. Then getting all of that prime factors into at this P vector. And then here, we are doing the main part of this particular question. That main part is that until a size of prime factorization, means this P is not equal to 1. Because when it becomes equal to 1, that is 5 equal to 5 would be there, right? Means prime factorization of 5 would be 5, right? So until this scenario is reached, till then we are doing all these things. So that's the thing which we are doing here. Now here comes the part, we are taking this new queue. Why we are taking this new queue is for the scenario, so that we can update the same. The thing is here we are declaring, initializing everything we are doing here. Then again if we do here this particular piece, then surely it will throw us some compilation error that we are redeclaring the same vector again and again, right? So that's why I use a new vector also here, so that it can redeclare it again and again. Now here comes the part. This sum is for the fact for converting our prime factorization into sum of prime factorization. So that's why I'm taking this sum part. So that this is that particular part of code which is doing this particular thing. Now here, this is that edge case. When 4 equals to 2 into 2, then it again becomes 4, right? So here n and sum, both are equal. So at that moment, I will be breaking out from this particular while loop and returning my n. So that's the thing which I am required to do here. Now here, I'm making n equals to sum, right? So that this n is now, either I can put this n also, sum also, either way it could be. So that we are again doing that prime factorization and getting the prime factors in this q vector and then equating with the new prime factors which we get from this q vector to our previous vector which was there, that is p, and then we are checking that what is the size of that p, is it equals to 1 or it is not equal to 1. If it is not equal to 1, then in that criteria we are again following this process. So that's the thing which we are doing here, and then at the end we will be returning n, because we are required to return the smallest possible sum of prime factorization which is being achieved till now. So that is the thing which we are required to do here. So now comes the part about the time complexity and the space complexity. So here, time complexity which goes here is all in the case of the prime factors only. So here, this order of log n is a function for prime factorization, right? And then we are doing this particular sieve operation, that is order of n log n. Now comes the part of our this particular, here we are just calling that order of n log n solution, order of n log n. The sieve, that is order of n log n. That was, wait, log of log n. And then this thing which we are doing, this is order of number of prime vectors which would be there, let us say p, the size of this particular vector and so on. And then again calling this order of n log n solution. So here, and then this while loop which is there, while loop goes ahead until we get that size equals to 1, right? So that is the scenario which is completely, we can say, equal to all this. So as per all these scenario, this is individually, this is also individually, but these are along with each other. So overall, as we see, the time complexity would be order of n log n plus the number of times we are calling this particular function. So if because that won't be, see that how it could be equals to n. It's like if it is equal, it can't be ever equal to n. It will be always less than n. That's why let us say that as L. So that's why n into L into log n, that would be the time complexity. And space complexity is purely for the vector which we are taking. So that is having L elements at max. We can't say it as n elements because there won't be any case any prime factorization where the number of prime factors is equal to the not equal to, but the, yeah, equal to n basically. Because see 15 is there, then the prime factorization for 15 was 3 into 15, much lesser. So that's why. So here the time complexity and space complexity for this particular solution. And yeah, this was all for this particular question. If you have any doubt, you could comment that down. And one more information about the same. So Newton School is also hosting contests. The way you are doing this bi-weekly and weekly challenges, then you can also try it with the Newton School contest because the top performer will be getting some exciting prizes. So I don't want to get those prizes. It would be like much more exciting, right? And also it will add up to your practice, right? So that's why about that you can figure out in every detail in the description below. there is one link in that every detail would be there. So yeah, this was all for this particular question. So yeah, thank you.